This was what voxel meshes used to look like in my game. For every single face, I used to just draw a single plane, even if loads of them were just absolutely the same. And obviously that's going to be a huge drain on resources, as well as making the files much bigger than they actually need to be. So this week I went on a journey of discovery and also slight madness as I went about implementing a face merging algorithm. Basically turning this into this. And spoiler alert, but the meshes are now all about a third of the size that they used to be. And so, here's how I did it. Like fundamentally what it needs to do, it needs to start at a position, expand along one axis, and then, once it reaches the end of where it can expand to that axis, start expanding upwards like this. So what you're trying to do is just determine how far you can build a rectangle along the series of faces. Every single voxel contributes a single face. Now that isn't very efficient at all. So what the algorithm ideally would do is do something like this, go down, and then it would try and expand in this direction, and then it would check to see if every single one of these faces can be merged. But it would find these and say, oh, it can't be merged. Okay, so I'll commit this as one face, and then it would do the same here, go down. Okay, we've reached the end. Can I go across? No, I can't. So this becomes one face. And it just essentially does that on repeat. I think the first thing to do would be loop over all possible faces. I actually took a moment to plan the algorithm out because I'm organized like that. And by the way, there are loads of algorithms to do this sort of thing. This is probably one of the simplest algorithms there actually is. Although I do also have plans to perform this in real time for my procedural terrain, so in this case a simpler algorithm might actually be better. Good morning. Actually it's not the morning at all. Good afternoon. It's taken a while just to get to this point and a lot of fiddling with weird numbers. What I'm doing is I'm starting to merge the faces. I'm going through and finding all the different face types, so that's what I'm doing here. I go through all of the faces that are wrapped and find the ones that I actually want to process in this batch. Put them into a data structure, which is this one I think, and then I go through in slices. So expand a 2D grid, because I take my 3D grid, I pick like one slice of it, and then go through that in a 2D format, and then expand those individual faces. And then what I'm doing here is pushing them into a set, and this is checking if something has gone wrong, or if you've actually got faces to merge. This is the bit where I do the actual check to see if it can be merged, and I haven't really confirmed yet to see if this is actually working. I'm really just trying to wireframe everything in place at the moment. But this is the first time I've run it and it hasn't crashed horribly. So this is my original faces as passed by the file. Now you can see it had 278 faces in here, and then I'm doing this function here to call the merge faces, which then produces 227 faces. I've got to admit though, it's not less in terms of the numbers I actually wanted, so I think there probably is something wrong with it. Okay, so I've managed to get this baby into a testing environment, and you can see it doesn't really do what it's meant to do. But it's better than nothing, and I'm glad it's actually trying to draw something. We're kind of getting somewhere. That obviously doesn't really look like what it should look like. Hey, there we go. So basically what I've done here is taken the original model, put it through the system but not removed any of the faces. So in theory now, if I was to actually start removing faces, I mean look at this, look, it's clearly taking two and merging them. So if I just work on this face, so looking at them side by side, you can definitely see it is actually working. Because you can see, so something like this bit here, it started here and it's gone down, and I'm just not drawing that because I haven't got the code to extend it in place yet. But these faces have been merged. And then for things like this one just goes straight down. So starts there and then all these have been cut off. The reason this is being drawn again is because it's got a different ambient mask. I need to get it to actually draw them going down. Which means that I have to make the face aware of how big it is as well as where its position is, because currently it's just hard-coded to be 1. You know, actually, I think that might have worked. Look at that! It actually worked! Damn! So I've, saved 3 faces there? This is probably like one of the meshes where it's not a massive improvement, but I mean still. Okay, there we go. I don't know why that one didn't go down. Oh, maybe it's to do with ambient. Maybe I could have an option to ignore ambience. So you can see what would have been these many faces and now would just be merged to 1. This is the sort of thing that I live for. So yeah, I mean, well, you can see how big of an optimization it's going to be once I get it through. So again, if I can disable ambient, then also that should get merged down as well. I thought you might want to see this. I mean, this is essentially just a showcase of how improved the new algorithm actually is. It's still like, I mean, you look at how many vertices would have been in this original one, where every single voxel was just a face, and then compared to the new one, like that is a huge improvement. And there's no like real decline in the quality or anything like that. So now I had the one face type working, I just had to get the others to work. But this ended up being probably the most painful part of the entire process. It was really fiddly to go through and get these different face types working, but after a day or so I was making progress. So here's some out of context clips of that work. 129. That makes 4. Debugger tries to interpret it as a char. Yeah! Okay. That looks a lot better. I'm just trying to... I'm trying to think out loud, like, I don't really know what's going on. Is this gonna work? I think it is. Like this without any optimization. Oh no. What? Why are you printing that? Oh no. Okay, that's why. I disabled the wrong one. Oh no. Okay, expansion on the other axis didn't work. God, what's happened to the positioning? It's wrong, it's totally wrong. 3 faces, that's good. It might merge them down. Yeah! I just got to figure out why it's putting it there. Yes! Ha! Oh. Lads. Oh. Thank God for that. And I need to have lunch because I waited till 3 o'clock because whenever I have lunch I get really sleepy. So by not eating now, I had more brain power to get this done. What a great day to be me. I can't do all the faces because I haven't got the flipping procedure in. So I'm going to get food and then I'm going to come back down and we're going to smash it out once again. So looking at them both side by side, you can kind of see actually how many voxels I've actually removed. Alright, look at this weirdo stuff. What is this doing? I mean, the good news is that from there it looks okay. Which should tell me it is just a problem with those types of faces. And as soon as you come up, and oh look at all the carnage that's been left behind. It just shouldn't look like that. Okay, that's looking good. Ooh! Yes, okay, that is correct. Because there'd be an ambient value there. Right, hopefully this is the last one. Oh god, I hope it is. What's happened? Ah! Is it done? Okay, it's fine from that angle. Yeah! I mean, look at the difference. That's a huge improvement. It's a third of the size. Hooray. Oh, I'm so happy. Nice. Oh, look at my little voxelizer. Look how reduced the trees actually are. I mean, there is clear merging going on. And the good thing is that nothing looks broken. I was slightly worried there was going to be some like weird one-off bug or something. Now you can see that the obvious slowdown is going to be on the terrain because, I mean, look at it. Look how many faces I've got to deal with there. So I wanted to show you this, which is yet another improvement I've made to the actual face processing thing. So you should be able to see that now the faces aren't actually being drawn on the bottom. Now for something like the tree, actually that's a good thing to do because you only ever look at it from the top. So you're essentially saving 9 faces to every tree by not drawing any of the bottom faces underneath, which you can't see anyway. So we've essentially halved the model by doing that. So it wrote 22 faces there, and then if I turn that flag back on, so what's 22 minus 9? It's 13. Yay, 13 faces. Now the last thing to do, the final step, in order to get the perfect, most optimized tree I possibly can, is these 2 things here. So they're 2, because this ambient calculation has gone, oh, I need to make sure that this has some shadow on it. So it split it off to 2 faces. So if I add another flag to be able to disable ambience entirely in the scene, then I'll get this down and I'll half the number of faces I need here. So it'll go from like what, 8 down to 4. We'd reach that perfect 9 faces, the most optimized tree possible. So let's do the ambient flag. Hey, 9 faces. That might have actually just worked first time. Oh. Yay! The perfect tree! I've dreamed about this day for a long time. With these trees as well, they're drawn with the shadow map. So you've got to remember that any optimization I can make to these is going to be huge. You can barely even see them when you've got the wireframe turned on. It's so much improved. The problem is the terrain. Look at how many rectangles are being drawn on the terrain. So that'll be a job for another day. Another week, I should say. because I'm certainly not doing it this week. The takeaway from all of this was that I managed to improve pretty much all of the meshes across the board by about 3 times. So the old built meshes took about 10.7 megabytes and the new ones take about 3.6. Now you might be thinking to yourself, well, 10 megabytes, that's not even that big, who cares? But I haven't really got that many meshes into the game yet, and you've also just got to remember that less meshes mean less vertices, which means more improvement, especially as I'm targeting like smartphones for this project. And speaking of optimization, why not watch this video where I make a palm tree model, which has definitely benefited from some of the mesh optimizations we've made.